Welcome to Geometry Pre-AP. Today we're going to talk about transformations and in particular the translation. You'll want to pause this video and you'll want to get all of this vocabulary down. You'll want to get the essential question written down, and I added this one other word vector down here at the bottom, so please get all of that information. Okay. Also, it's important is that I added in right here that rigid transformation, also known as an isometry. So pause the video, get all those things written down. Also, make sure you have your title. All right, so some of the first concepts we need to deal with here are just getting to understand that, sorry about that, some of the vocabulary that's involved in this. So first we have just a basic transformation. Definition is a function that maps every point. So J goes to J prime, K goes to K prime, Q goes to Q prime. And so triangle JKQ transforms to J prime, K prime, Q prime. Okay, and so you'll want to get this information down. Make sure you get the vocabulary up here. You can draw this image and this information. All right, so vectors. I'm going to see if I can make this a little bit bigger here. So we're looking at vectors. A vector is a directional ray. It has a different kind of, it doesn't have parentheses around it. It has a different kind of bracket, which is uses these. All right. And so vectors have what's called a component form, which is the way we write them. So vectors component form has a horizontal component and a vertical component. And so therefore, this vector has a horizontal component of 5 to the right and 3 up. So that's written like this. We use the symbol for vector is like this one, FG, with like a half ray over it. Okay, has an initial point, which is a starting point, and has a terminal point, which is the ending point. All right, so take a minute, and so if we look at this one down here, if you want to pause the video and write that stuff information down, that's great. So if we look at this one down here, I'm going to do the first one, and you're going to do the second one. So this first one here, if I look, it has a starting point of C and a terminal point of D. So this is going to be vector CD. Its component form is, and as we look at that, it has a horizontal component of this direction this way, which is 7, and a vertical component, that's positive 7 and negative 3. And so therefore, my component form of my vector is 7 comma negative 3. When you're going to find the magnitude of a vector, it's basically Pythagorean theorem. We take these two numbers and we put them in Pythagorean theorem. So that would be, oops, that would be 7 squared plus 3 squared, which equals the magnitude squared. And so when we finish solving that Pythagorean theorem, we get the square root of 58. So the magnitude of that vector is square root of 58. So your turn will be to do the one next right here. Pause the video and do that one. If you end up having any questions, you can ask me in class the next day. All right, so we want to get some of this information written down. Pause the video and write this information down. We have the translation. And translation means we're mapping all the points, or moving all the points from the original pre-image to the image, which was written on the first page for vocabulary. And so A goes to A prime, B goes to B prime, C goes to C prime. All right. And then once you have that one done, a translation has a form to it. And so as we look here down at the bottom, it shows us that we can write a translation with a T and 4 comma negative 2. That's the vector form. And so what I really want you to get out of this is that when you do a translation, you're going to need to be able to write this, or I'm going to give this to you in a problem. This is our transformation mapping version. So xy changes to x plus 4, comma, y minus 2. And know how to write this because I'm going to ask you to write this all the time. Where we're adding a number to the x, which is our horizontal component, and we're subtracting a number from y, which is our vertical component. And so that moves every x 4 to the right and 2 down. All right, so a rigid transformation. A rigid transformation is a transformation. If you went back to the definitions that you recorded and that you wrote down at the very beginning. So we have a pre-image and we have an image, and we're asking, is this a rigid transformation? If it's rigid, then the two figures are congruent. Their angles are congruent, their sides are congruent. So is this a rigid transformation? Oops. No, this is not, because size is not preserved. Congruence is not preserved. Angles would be congruent here, but the sides are not congruent. All right, so it says here, what is the image for angle F and angle H? So if we look in the picture for angle F and angle H, the images would be angle F prime and angle H prime. And so then we're also looking at what are the pairs of the corresponding sides. So we have side EF, FG, GH, and EH, and what would be its corresponding sides? So EF would correspond to E prime, F prime. FG would correspond to F prime, G prime. EH, EH prime, and so on and so forth. Okay, this is just getting you to pick out the corresponding pieces of information. Okay, so let's get into our first little transformation here. It says find the image of a translation, and so we have the vertices of the transformation. Our translation are -2, -5. And so you want to think, what is the movement of that? And that's 2 to the left and 5 down. So we start off with identify each vertice, so make sure you write each order pair. That's probably one of your first things you want to do because I've seen many people miswrite your order pairs. Then we want to make the move. So we take each order pair. So the first one was 2, 1. And we subtract 2 and subtract 5, and so we get 0, -4. Same thing for the next one is 3, 3. And so we get subtract 2 and subtract 5, and so on and so forth. And we get them all done. Once we have that done, we draw the figure on there, and then we reconnect all the points. And this is a translation. Everything went 2 to the left and 5 down. Make sure you label those prime marks. If those prime marks aren't there, then you'll have points deducted on the quizzes or tests. All right, so describe the rule. This is another big thing we're going to ask you to do on the test, is to actually describe the rule that was done. So what is the coordinate rule that describes the translation that maps PQRS on a P prime, Q prime, R prime, S prime? All right, so some of the things we need to know. Coordinates of the vertices. How do we go from one vertices to the next? Is this a rigid transformation? If it is, then we only have one rule to worry about. And then we write them out. So first things first. Our image for P prime is 5, -2. Our pre-image was -3, 4. So if we look at that, we have a horizontal component of we added 8 each one, and we have a vertical component that we subtracted 2 to each one. Since we have that, we can write our matrix. And so remember that I told you that I want you to write it in the correct way. So x, y changes to x plus 8, y minus 2. Oops. And this is how we want this one written at all times. So make sure you write that like that. If you don't, I'm not going to give you credit. I don't want this transformational function notation, even though it has a vector down there. You do need to know how to write that vector, and you do need to create the magnitude of the vector and things like that. Okay, so you're going to pause this video, do this page. Okay, I will show you a couple answers, but not all the answers. So here are the answers to this one. Whoops. I'll give you this one, and I'll give you that one. All right, down here, I have you practice these two. And so you should have done these also. And so I'll give you just one of the answers. If you need the other answer, you can ask when you come to class. All right, so here it says find the values of x. Remember, this is a translation, so this is a translation. Remember that it's rigid, and so therefore it's rigid. Congruence is kept. If you need the answer to this, ask when you come to class. So pause that video and do this. And finally, here, this last one. If a is 3, 5, change to a prime negative 1, 8, write the motion rule. Okay. And of course, write these things down, especially the blue parts. These are things that you should be able to do now that you've finished this video. And that is the end of the video.